Hi guys, today we're going to talk about analyzing and sketching graphs. So graphs can show the relationship between quantities without using specific numbers on the axes. So if I look at this graph right here, we have distance over time. Okay, so what I can tell from this graph is that for this part of the graph right here, this graph, the distance is getting greater. Okay, so the distance is getting bigger at a constant rate. Now, you might question that it's a constant rate because you think, okay, a constant would be horizontal line. But the rate is constant. The rate is staying the same all the time. In this case, it's going up 1 over 1, up 1 over 1, up 1 over 1. The slope is always 1 in this case. Okay, so the distance is getting bigger, and the rate is constant, and it's getting bigger. Okay, now, what's happening here then? Well, the distance is not changing. So this would be something that has stopped. It went away from me for a while, it stopped, and now it's just sitting in place. So the distance is not changing. Okay, during that time period. Now, what's happening? What's happening here? Well, the distance is getting to be less. It's at a constant rate because it's a nice straight line. Okay, so the distance is decreasing. At a constant rate. Now, here's what I can also tell. This distance is, this thing is closing on, the distance would be 0 right here. It's closing much faster than it was going away because the line is steeper. Okay? So I can tell that from the chart. Now, I don't have any numbers. I don't know how far away it is because I don't know how big these squares are. But I can make those observations. Okay, so the graph showed temperatures throughout the day in 2 cities. Describe the change in temperature in each city. So this is Milwaukee, Oregon right here. Okay, so what's happening to the temperature? Well, the temperature is getting bigger and bigger and bigger, and then it's evening off, and now it's decreasing. Now, what's happening to this? Now it's increasing, the temperature is increasing on this half of the graph right here. Okay, you know what, that's really hard to read, so let's try this a different way. Let's see. Okay, now let's take this. It's increase. Whoa, we don't want to do that. It's increasing along here. Okay, now it is increasing at a decreasing rate. So it's increased, the temperature is increasing pretty fast right here, and the temperature is still increasing, but it's slowing down in how much it increases. And now it's increasing very slowly right here. So we would say that it's increasing at a decreasing rate. On this side. Now, once it reaches here, whoops, that's not what we want to do. once it reaches this point right here, now it starts decreasing in temperature, okay? So over here, it is decreasing at an increasing rate. So how does that work? Well, the temperature's going down, and it's getting a steeper and steeper slope on this thing, so it's decreasing at an increasing rate. It's getting colder faster during this time. So there we go. Now let's look at this. This is Newport, okay? So this is the temperature. Oh, look at this. It's plunging pretty fast right here. But it's a constant rate because it's a straight line. So here the temperature is decreasing at a constant rate. We'll say at a constant fast rate. Okay. Now, the reason we say that is because right here, it's still decreasing. It's still constant. But it's a slower rate. Okay, this is a much slower rate of decrease right here. So it's going really fast, and then it slows down, and then, oh, here it evens out. Okay, so what's going on here? Temperature is not changing. The temperature is remaining constant right there. And then finally, over here, it's increasing, also at a constant rate. Anytime you see a straight line like that, it's going to be at a constant rate. Okay, now this one, it's faster than it was decreasing here, but it's slower than it was decreasing here. Okay, so I can get all that information off those graphs. I don't even have any numbers. Sketch a graph that represents each situation. So a stopped subway train gains speed at a constant rate until it reaches its maximum speed. So if we were going to draw that, it's stopped, so it's just sitting here, right here, say that long. And now it's increasing at a constant rate, okay, until it reaches its maximum speed. So let's say it goes to here. Now it's its maximum speed. It travels at this speed for a while, okay, then slows down at a constant rate until coming to stop at the next station. So it's coming down here, and then it would be sitting there like that. Now, it just so happens I made these kind of the same right here. They don't have to be. It could speed up really quickly and slow down really slowly. We don't know. Okay, as television size increases, the price increases at an increasing rate. Okay, so what does this look like? Well, this is the size of the TV here. The size of the TV increases. The price goes up at an increasing rate. So it's getting faster and faster and faster. So that would look something like this. Okay. The price, as the TV gets bigger, the price increases at a faster and faster rate. And you can actually see that that's true. If you go price of TV, the different sizes of TVs. Okay, now you do this. So you're going to pause the video and you're going to figure this out. A fully charged battery loses its charge at a constant rate until it has no charge left. You plug it in and recharge it fully, then it loses its charge at a constant rate until it has no charge left. Okay, So go ahead and pause the video, sketch that out, and see if you got it the same thing as I'm going to get. Okay, so we got a fully charged battery. So let's say this is fully charged right here. And it runs out. Ooh, that's ugly. We have to run out quicker now. We're going to run out of room too. So it runs out really quickly, and then then it's got no charge. Now it charges back up, and then it runs back down again. So it should look something like that. Usually it takes a lot longer to charge something than it does to run it down. Okay, so we're going to do 1 through 23 odd in class next time. Look forward to seeing you guys. Talk to you later.